have writing utensil at the ready?
Thank you.
Worksheet in class 64. Let's go through some answers.
I need a pen.
Correct. Move this on screen. I'm not sure how much good it'll do, but
Oh, please don't.
hi, Catherine. Okay, here we go. 27. Everybody ready? None at the ready? Good. 27. X squared minus 100, or plus negative 100. Number 28. 25x squared minus 1, or plus negative 1. 29. 49x squared y squared minus 9t squared. You could also have plus negative 9t squared. Number 30. 49 minus 9x to the fourth. You could also have 49 plus negative 9x to the fourth. Next page. 44 factors twice. First, you can pull an x plus 7 out in front. Let me get my own copy.
Hey, we skipped 30.
Yeah.
Oh, whoops, sorry. Yeah, so actually 30 was 49 minus 9x to the fourth. 31, sorry. Oh, heavens, no murder right. Wow, we skipped a huge. I forgot to hit the down page, sorry. 31. X plus 6, x minus 6. You can also have it in the opposite order. John, question.
Ace restroom.
Get it right back, yes. And get the answers that you missed from somebody. 32. 12 plus 7x, 12 minus 7x. Number 33. ABC plus 1, ABC minus 1. 34 is prime. 35 factors twice. First, you pull out a GCF of 3. So it should be 3 parentheses x squared minus 9. Then that factors by difference of 2 squares. So the final answer should be a 3 in front, followed by x plus 3, then x minus 3. Can you repeat so far? Up to number 33. Sorry, number 35. Number 36, it's a similar problem. There is a GCF of x. Pull that out in front first. That'll leave behind x squared minus 4, which factors by difference of 2 squares. Final answer should be an x in front, followed by x plus 2, then x minus 2. Number 37. All it has is a GCF. The GCF is negative 8 x to the fourth. Then inside is x plus 2. 38 unfoils x minus 5, x minus 6. You can always do plus negative. And it repeats up to number 38. Yeah. 37, yeah. Negative 8 x to the fourth, and then parentheses x plus 2. Any others up to number 38? All right, number 39. This factors twice. There's a GCF of 4. Did anybody split this into 2x plus 12, 2x minus 12? Yeah, that's tempting. The problem is there are 2 little mini GCFs still in those parentheses you'd have to pull out. There'd be a GCF of 2 in the first parentheses, GCF of 2 in the second. You could. You'd have to pull the 2 and the 2 out in front, which would become a 4. It's easier to pull out the GCF first. This is one of the problems that shows why GCF first is very, very good. Pull out a GCF of 4. You should be left with x squared minus 36. So that splits by difference of 2 squares. Final answer should be a 4 in front, followed by x plus 6, followed by x minus 6. Again, if you did the 2x plus 12, 2x minus 12, I would give you half credit for that. If you pulled the rest of the 2's out in front and got 4, x plus 6, x plus minus 6, totally fine. I don't care how you get there as long as you get it correctly. Number 40. That factors twice. there's a GCF of x plus 3. Pull that out in front. Then the other part factors by difference due squares. So you should have 3 parentheses. X plus 3, x plus 4, x minus 4. Okay. Number 41, x plus 1, x minus 1. Number 42 is prime. Yeah.
For the difference in two squares, is it okay to do like x plus 1, x plus negative 1?
Absolutely. Yeah, that's always fine. Good question. Everybody okay up to number 42? 42 is prime. 43, factors by grouping. Should have an x plus 5 out in front, followed by x squared plus 7. 44 factors twice. First, you factor by grouping. It'll become x plus 7 and x squared minus 4. That factors by difference due squares. So you should have x plus 7, x plus 2, x minus 2. Did you catch that? 45, that factors by difference due squares. 8 to the third plus 5, 8 to the third minus 5. Question, Eric?
Can you repeat 45, 44?
44 is it? Okay. 44 is 3 parentheses. X plus 7, x plus 2, x minus 2. Everybody okay for number 45? Yeah. 45. 8 to the third plus 5, 8 to the third minus 5. Okay. 46 factors by unfoil. X plus 20, x plus 2. 47 factors, I'll accept 2 different ways. You could unfoil it, or you could do binomial squared. You could do x plus 11, x plus 11, or you could do x plus 11 parentheses squared. 48 is prime. 49 factors twice. Pull out a GCF of 7 first. Then the remaining stuff factors by grouping. So you should have 3 things. A 7 in front, then an x plus 2, then an x squared plus 2.
I did the grouping first and then pulled out the GCF. So
Okay.
like I have it written x plus 2 in parentheses and then a 7 and then the other parentheses. Like,
Okay.
'cause I didn't know if that, like if I should, if I.
Okay.
then-
That's legit. Just pull the 7 all the way in front.
Okay.
Yes, that'd be fine. As long as all the parts get out, that's fine. If you leave the GCF in one of the parentheses, then you start losing points. That was number 49, and number 50 is prime. And it repeats up number 50. All right, open to questions. Yeah, go for it. Yeah. Yes, go for it. Yes. Any math questions? Go.
33.
33. Take a look. Right. A squared, b squared, c squared minus 1. Now that's 2 terms. The first thing is a big term, but it's a term. It's all welded together. So let me move this thing out of the way. Make sure it doesn't collapse. So how do you do that? If you notice the first thing, anytime you have 2 terms, you start thinking to yourself, could it be by difference due squares? Because it needs 2 terms. If it's a blob minus a blob, at least consider difference due squares. It might or might not work. Does this look like it might be something squared? Do you think they squared something in order to get this?
Yeah.
Like what?
A and B and C.
Yep, A, B, and C, and then that'll be over here too. Is this something squared? Like what? Yeah, it's 1. A lot of people are tempted to do 1/2, but that's adding. This is 1 and 1, and how do you fix this for your final answer? For difference due squares.
Subtract it.
Yep, and then,
Add it.
yeah. And I don't care what order you do them in, that's your answer. Makes sense. Basically, anytime you have a difference due squares, if you have a squared minus b squared, a blob squared minus a blob squared, it always falls apart into a plus b, a minus b. That's difference of two squares. Yep.
You did 32.
32, Suzanne, okay. Yeah, 144 minus 49x squared. Does this look like it might be a difference of two squares? Rob? Yeah, might be. What did they square to get this? 12. So if we're doing difference of two squares, it's going to be 12 and 12. Does this look like a square?
Yeah.
Like what?
So
7x and
7.
7x. How do you make it look like a difference of two squares?
12 plus 7 is 12
Done. Okay. Make sense? Next. Any of the other ones that, no matter how humble or how complicated, now's a good time to ask. Because the next method is going to be yeah.
Can you do 40?
Which one?
40?
40. 40. Yeah. By the way, it's not horrendous. It's just, it does make people's eyes cross a little bit. Number 40. X squared parentheses x plus 3 minus 16 parentheses x plus 3. So you tell me, what's the first type of factoring you always look for?
GCF.
Is there one?
X plus 3.
And x plus 3. We're pulling the x plus 3 out in front because it's common factor. What's, give me parentheses with the leftovers.
X squared 16.
Minus 16. Good. Is that factor?
Yeah.
Yeah, by what method?
The 2 squared.
Difference of two squares. Do it for me. The x plus 3 is just going to stay there. Okay. Then what?
Is it X plus 4?
4. Good.
And
And
X
then x.
minus 4?
You got it. That's it. That's my answer. Once you get down to the point where there's no more x squareds or x cubes or anything, you can be pretty sure you're done factoring. Because x doesn't split anymore. It's just x. X squared splits into x times x. But once you get to x, 95, 98% of the time you're done. Questions? Someone, go.
Can you do 44?
44. Yeah, x cubed plus, can you read it out for me?
Sure.
Okay, x cubed plus something.
X cubed plus 7x squared plus negative 4x
Okay,
plus negative 28.
negative 28, good. You tell me, what's the first thing we always look for?
GCF.
GCF, is there one?
Or no.
Which one?
I don't know.
Don't try and read my face. Scan and see, is there anything you can pull out of all 4 terms at the same time? No, you are correct. Except what? Technically, 1, which I wouldn't. Yeah. Unless you have an emergency, like factor by grouping. So after that, how many terms does this have? What does that remind you of? Grouping. Let's try it. Nothing to lose. Is there a little miniature GCF for this pair?
Yes.
Like what?
X squared.
Yes, you can pull an x squared out. 2 x's can pull out. What's left behind?
X plus 7.
Okay. Plus 1. Mary, take over. Is there a little mini GCF here?
Negative 4.
-4. Why negative and not positive?
Because you have to pull out the negative.
Right. If the first term, if the first term is negative, you have to pull out a negative. What's left behind?
X and 7.
Positive or negative? Yes, x plus 7, because the negative got yanked. Is this going to work? Yes. What comes out in front?
X plus 7.
Good. X plus 7 comes out in front. What's left behind?
Still
Please.
X squared plus negative 4.
Right, x squared plus -4. This is one of those rare times I'm going to change the notation to x squared minus 4. Any idea why? Normally I hate subtraction, yeah.
To do the, I forgot what it's called.
Okay, the difference of two squares. Go ahead and do it. What does it split into? X plus 7 is good.
X plus 7 and X plus
plus 2,
X
x minus 2. Okay. Does that make sense? Next. Any other ones you want to see? Go.
Can you do 45?
45. Yeah. 8 to the 6th minus 25. Yeah, look up here. This is a little harder to see, but anytime you have two terms with a minus, think at least maybe it could be difference two squares. If it is, the first thing is something squared, the second thing is something squared. So John, tell me, where does 25 come from?
5 and 5.
5 and 5. And I'll bet you if it works, it's going to be plus minus. Where does 8 to the 6th come from? And they have to be equal. 8 to the 3rd. 8 to the 3rd times 8 to the 3rd is 8 to the 6th. A lot of people think 8 to the 3rd times 8 to the 3rd is 8 to the 9th. But the rule, exponent rule, says you add the powers. So you're done. Any others you want to see? Now's a good time to ask. Yeah.
I was kind of confused in 44. They had the,
Okay. Right here?
Yeah.
Okay.
They had the.
X squared plus negative 4?
No, in the top it said.
Oh, okay.
Negative 7x squared minus 4x and then minus 28.
Okay, I always do add the opposite, Yeah. I would strongly suggest you do too. It'll make this a lot easier. Otherwise, it's really, I agree, it's really hard to know how to factor by grouping. If there's a minus in here, yeah, you might accidentally think this is positive. It's not. So, any others? Sure. Going once. Twice. Thrice. Quatorze. I made that up. All right. Take out your notes, please. This is arguably the weirdest factoring method, but it's arguably the most powerful. This is what I sometimes affectionately call the bazooka of the factoring world. It pretty much takes out anything that you want to factor with it. So the good news is if something factors and it's if it's power 2, like the highest power is 2, if it factors at all, this will factor. Like, even if you forget how to unfoil, you forget how to difference two squares, binomial squared, this will factor. That's the good news. The bad news is it takes longer than the other methods. But another piece of good news, it will factor things that the other methods won't. 3x squared plus 2x plus negative 1. No like the fact of this. Go ahead and write that down in your notes. We have 5 methods of factoring in our tool belt right now. Rosie, name the first. GCF. What's the second? Yeah. Starts with a U. Unfoil. Now, what's the third? Starts with a B. Go. Binomial squared. The fourth starts with a D. Go. Difference of two squares. The fifth, what's the only other one we've covered so far? Go. Grouping. Next. So we've got GCF, unfoil, binomial squared, difference of two squares, grouping. Let's check here. Is there a GCF to pull out on this one? No. Except for what? Technically. 1. And would you do that in this case? No. The only time I've ever seen 1 pulled out in front usefully is in factor by grouping. And that's if you absolutely need to pull out something. And this definitely isn't it. So no GCF. Can we unfoil? Can we unfoil this thing? Unfoil is where you find two numbers that add up to the middle number and multiply to be the end number. But there are conditions where you can use that. The conditions are 3, 2, 1. I remember what those stand for. unfoiled obeys 3, 2, 1. 3 what? Go.
Return.
3 terms. Well, that's good. 2 what? Yeah.
But it looks like
The degree. What does degree mean? Yes.
the
Highest exponent on a variable. So the degree, the highest power in there has to be a 2. That's actually good. We got 2 out of 3 is good. Yeah. The lead coefficient has to be 1. There has to be a 1 in front. Unfoiled fails. So that's it. So everybody okay? So GCF fails, unfoil fail. Unfoil doesn't work. And binomial squared, would that work? Does this fit the binomial squared pattern? Square the first, double the product, square the last. Does this look like a square the first? In your opinion? No. If this had been 4x squared, I might have gone for it. 3x squared, the 3 doesn't, it's not a square. Does this look like a double product? Yeah, it could. 1x doubled. Does this look like a squared last? Oh, math people. It's deceptive. My answer? Heck no. Why not? It's negative. I dare you to find something squared that's negative. Doesn't happen. There's no real number that does that. If this had been positive 1, and if this had been positive 4x squared, I might have tried it. But this, not so much. So, binomial squared? Can we do difference of 2 squares? Jack Gilbert. Does difference of 2 squares fit this? No. What's wrong with it immediately? Difference of 2 squares is a lot like this. It's like we were doing before. Like that. There's 3 terms. Yeah, that immediately kills it. And there's no subtraction sign in the middle anyway. So not difference of 2 squares. How about factor by grouping?
No, it doesn't work.
Why not?
Because that has 2 terms and you only have 4.
You need 4 terms for factor by grouping, and I only have 3. So all the 5 methods we know have failed. Looks like we're doomed. Except, there is a method, although I have to tell you the story beyond the name. The name sounds a little goofy. It's called magic pair. I actually grew up, I went through Algebra 1, just like y'all. You actually went through it earlier than I did. I had it as a freshman in high school. And they never taught this method to us, magic pair. It was not in the book. I discovered it when I was teaching, there was a college class I was teaching on people who needed to catch up on algebra. So I was teaching that down in Illinois, and down over in Illinois, you know what I mean, whatever. It's still beyond in Illinois.
down.
Yeah, it's down and over, you know, whatever. But when I was teaching the course, the textbook had this. And I looked at this and said, holy mackerel, where have you been all my life? You know, why didn't they teach this to us when I was going? All we had was, like for this, the way we did in high school, we put parentheses, a whole bunch of pairs of parentheses, and we guessed and checked. And I said, maybe this will work, maybe this will work, maybe this will work, maybe this will work. And we tried them all and foiled them all to see if any of them worked. And if they didn't, 5 minutes later, or 10 minutes later, we find out, okay, it's prime. If only. But the book that I was teaching in didn't give it a name. It just said, use method on page 45. It's not going to help you much because like page 45 of some book in Illinois is not going to help you. So I went looking. The only place that gave it a name was on somebody's blog. I was a math geek blog. Okay, I serve math geek blogs. I'm a math geek, so I actually subscribe to a math joke website. But some of them are pretty funny. I got to tell you some later. But magic pair was the name they gave it, and I said, okay, this is the only name I've ever seen for this ever. So I decided to steal it from her. I don't know who it was on the blog. Here's how it works. Circle the first term and circle the last term. And draw a little bracket between them. And write the word multiply. You don't have to do that every single time you do this. This is just to show you. What I'm gonna do is multiply the first term and the last term. Tell me what I get. Yeah, negative 3x squared. Draw a line underneath that. I want to list all what I call the factor pairs. Let me explain what that means. Like, a factor pairs might be, like if you started with the number 16, it's like 1 times 16, 2 times 8, 4 times 4. Does that make sense? Those are factor pairs, they multiply. There are actually 3 more. Can you think of them? Yeah. Negative 1 times negative 16. Negative 2 times negative 8. Negative 4 times negative 4. Exactly. So look carefully. You may have more pairs than you think. But I want to find a pair that multiplies to be negative 3x squared. That's a little weird. I will tell you, each one, each term has an x. Okay. So I usually like to start small. So 1x times, somebody tell me what would go with that? Yeah, to make this. Negative 3x. Does that make sense? So there's the first pair that'll work. Does 2x go into this or no? Anyway. If I'm multiplying, 1x works with negative 3x to multiply. Would 2x work with anything? No. How about 3x? Yeah, 3x times what? Is that a repeat? No. The signs are different. That's actually all the pairs that ever will work on this. That's actually kind of lucky. There are only 2 pairs to look at. Everybody okay so far? So those are all your pairs, your factor pairs. What I want us to find, is there a pair that adds to the middle term? It's a lot like on FOIL. Do one of those pairs add up to the middle term? Do one of those pairs add up to positive 2x? Yeah. The second one. Circle it. This is called the magic pair. Let me stop there for a second. This should be kind of mysterious. It's kind of like we're walking through the weeds trying to figure out where in the world are we going with this. Multiplying the first and last terms is strange. Splitting this up, we kind of did that with on FOIL, trying to find 2 numbers that add up to blah, 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 and multiply blah, blah, blah. And then so this is kind of like on FOIL. So these 2 multiply and add up to the middle term, kind of like on FOIL. But what do we do with it? Here's where things get super duper strange for like 10 seconds. But there's a really nice surprise at the end of the strangeness. How do you know this is the right pair again, Eric?
By adding them.
Adding them, and they add up to what? To the middle term, to 2x. Do me a favor, put an addition sign there to remind us of that. Random question. If I walk up to you and you have a $20 bill, is it legal for me to take, with your permission first, to take a $20 bill from you and give you 2 tens? Yeah, why? Why is that legal? Yeah. Same amount of money. Is it legal for me to take a $20 bill and give you 2 ones? No, that's called theft. That's a misdemeanor. I'd be in jail for 30 days. Then I just stole $18 from you. So, does that make sense? In other words, you can only substitute something if it's equal, of equal value. So, hey, let me take that $20 bill off your hand. Here, take these 2 dimes. They're nice and shiny. No, it doesn't work that way. You can substitute any 2 things that are equal. What did you say the 3x plus negative 1x was equal to? Go ahead, Rob. 2x. Draw an arrow here. I'm going to plug it in. Plug the magic pair in place of the second term, the middle term. Can anybody tell me what that would look like if you actually did that? John, tell me that. Just replace the 2x with this thing. Like from beginning to end, what would it look like? What's the first term? John, go.
What?
Read that off for me, but instead of 2x, replace it with the magic pair.
Oh, 3x plus 3x.
3x,
Oh, 3x
squared
squared.
plus
Plus 3x.
3x.
Plus negative 1x. Plus negative 1.
Exactly. See what happened? The middle term got replaced by the magic pair. You might be thinking, Mr. Gallagher, you just made it worse. With all due respect. You made it so that the original problem only had 3 terms, now I have 4. Any sneaky person predict what we might be doing next?
Grouping?
Factor by grouping. By the way, if a magic pair exists, factor by grouping is guaranteed to work. It will always work. If there's a magic pair at all, this thing will work. Rosie, tell me what the mini GCF is here.
3x.
3x. Now be careful of the second term. What's left behind?
X.
Plus what? A lot of people are tempted to leave it blank.
1.
1. Nice. Did you see why there's a 1 there? People think, well, you pulled the 3x out, why isn't it blank? You're dividing it out. You're dividing both of the, you're undistributing by 3x. 3x divided by 3x is 1. Can somebody do the second pair for me? Let me see. Isabella, what's the GCF of this pair?
-1.
Nice catch. -1. Tell me what's left over.
X.
Uh-huh.
Plus
1, because the negative got yanked. Is this going to work?
1. Yes.
By grouping? Tell me what happens now. What do you do with this pair?
You make it x plus 1.
Yep, pull it in front.
Yeah.
So x plus 1 in front, and then give me a parentheses for the leftovers.
3x plus -1.
You're done. That's factor by magic pair. It's like 5 steps. Multiply the first and last, then list the pairs, the factor pairs, then circle the magic pair, then replace the middle term with the magic pair, and factor by grouping. Does that make sense? I'm going to do another one, but I'll leave that up there. Yeah. Question?
Can I call the factor pairs to 3x squared times?
Oh, good question. Each term has to have an x. So yeah. Short answer is no. They have to be balanced. Very good question. I tried that once when I was first learning this method, and it didn't work. Try this. Example. 6x squared plus 7x plus -3. I'd like you to factor this thing. Yeah.
I have a question.
Yeah. Okay.
I don't know if this would work for every single one, but I don't know. So instead of like doing like the -3x squared and going through all those steps to get the magic pair, could you just do the 3x and then move one of the x's to the -1?
This -1? Oh, the fact that this is a 3 and this is a -1, and this is a 3 and this is a -1, total coincidence.
Okay.
Yeah, very good catch. But yeah, I'll show you over here too. They won't match. That would, I never even noticed that. That's really awkward. 'Cause you remember when you're first learning addition and multiplication? Like, or if you've ever seen like little kids learning their multiplication, and they do like 2 plus 2 is 4, and 2 times 2 is 4, and all these little kids are going, I understand. 3 plus 3 is 6. 3 times 3 is 6. I understand. And the teacher's like, no. That's an accident. That's really. No, but it worked once. I know it worked once. 1 times 1 is, I know. 0 plus 0 is 0, and 0 times 0 is 0. It worked twice. Somebody take me away. So, that's an accident, that's an unfortunate accident. Somebody talk me through this. First of all, is there a GCF? We should always look. Is there a GCF on this thing? What do you think? No, there is not, other than one, which is pretty useless. Yeah.
Does that mean all the problems we had were actually primes and we can actually use magic there?
Maybe. There were a lot of them that are actually prime. There were a few in the previous problems that, do you remember the one worksheet where I said, instead of writing prime, I had you write not a binomial squared? There's a reason for that, actually. Because some of them can actually factor by magic pair. And we didn't know that, so. Yeah, maybe. So, can somebody talk me through this? There's no GCF. Question, let me see. Jack Edward, can we factor by unfoil? That's the add up to this and multiply with this thing. There's a rule for unfoil. 3, 2, 1. Does this obey that? No. There are 3 terms. I like that. There's the highest power of 2. I like that. What does the 1 mean? Go. Yeah, there has to be a 1 in front of the x squared. 3 terms, highest power of 2, 1 in front. And that got spoiled. So no unfoil, unfortunately. How about binomial squared? Does it fit the binomial squared pattern? Here. What's the 3-step pattern for binomial squared again? Yeah, square the first, double the price, square the last. Does this look like they did that? Does this look like squared first?
No.
Like, correct, it's not. I like the x squared, but I don't like the size. 16x squared, yeah. 25x squared, sure. 6x squared, no. Does this look like a squared last?
No.
Heck no, it's negative. Does this look like a double product? It's not, I suppose you could, 3.5x and 3.5x. It does happen every once in a while. But I would say no, this thing is a complete failure for binomial squared. Is it a difference of 2 squares, Isabella? Could we use difference of 2 squares on this? Why not? You're right. What does the difference of 2 squares look like? Kind of hence the name. Difference of 2 squares. True, there's no other square. And even worse, how many terms do you need for difference of 2 squares? Hence the name.
Oh, 2.
2, right. It's a square minus a square. This has too many terms. So, can we factor by grouping? Rosie? No, why not? Right, it doesn't have 4 terms. Looks like we only have 1 choice left. Somebody talk me through this magic graph. Who's feeling brave? Or reckless? Go for it. Mary, help me out. What's the very first step? Before that. That was step 3. Way at the beginning, I circled something. Well, that's true. I forgot about that. So,
Circle the
first and last terms. Everybody do that. Circle the first and last. Let me just list the steps for you. Circle the first and last terms. And multiply. Go ahead and do that for me. What is 6x squared times -3? Good. -18x squared. That's step 1. Step 2, list all balanced factor pairs. By balanced, I mean each one has an x. So let me see. Trying to take over. Start small. Like, what's the smallest number you can think of? Other than 0.
1.
Which would be 4 over 1. That's 1. Yeah. So 1x times what?
8.
Make-
-8.
Good. -18x. What's the next one that could work? Does 2x work?
Yeah.
Yeah, 2x times what?
-9x.
Okay. Now brace yourself. Brace yourself. This is gonna have more pairs than that one. Give me one more. Does 3x work?
Yeah,
Times what?
-6.
-6x, nice. Go.
Could you do negative 1x times 18x?
Yes, you could. As a matter of fact, I'm gonna get to it down here. Yes, and I'm actually glad you mentioned that. Actually, take over. Does 4x work
Yeah. Times.
for this?
Oh wait. No.
4 does not work. How about 5? How about 6?
Yeah.
Ah, so 6x times what?
Negative
-3x. Is that a repeat?
3. No.
No, it's not. They have different signs. Keep going. By the way, everybody look up here. This is a time-saving hint. You notice how I just sort of had a mirror image over here? Can anybody predict the next number that's going to work? 7's not going to work, but yeah. 9. Once they start mirror imaging, I guarantee, guess what the next one is? I pretty much guarantee it. There's just one more. It mirror images all the way up. Once you start mirror imaging, you can just keep going. And you can actually mirror image the other ones too. 3, this is going to be -2x and -1x. Does that make sense? And that's the pair that you were talking about. It'll show up eventually, although it might be backwards. Questions? So there's all your pairs. That's step 2. Step 3, find and circle the magic pair. How do you know it's a magic pair? How do you tell? Rob, how do you tell if a pair is a magic pair? Right, if it adds up to 7x. If it adds to be the middle term. Sorry, I'm writing so small. If it adds up to be the middle term. Do we have a magic pair in here? Andy? Do any of those add up to positive 7x? Which one? There you go. The 5th pair down there. Up here, 2x times -9x was tempting, but that adds up to -7x. That's another hint, by the way. Did anybody catch that? Like when we were first writing the pair? They say, ooh, 2 and -9, -7. Oh, darn it. Wrong sign. As soon as you have the right number and the wrong sign, you can sort of jump down to the mirror image and you'll be done. Like if I need like 15x and I got something up here that's -15x, jump down to do the mirror image and I guarantee you don't even have to write the next of these. Because I've seen some problems of these where like 24 pairs or 36 pairs. It takes forever. But if you find something really, really close to the pair, you can just jump down to the mirror image, save yourself about 5 minutes worth of work. Go.
On the homework, do we have to write all of the pairs down, or can we just?
Oh, good question. The question is, do you have to write all the pairs down? The answer is not necessarily. If you can find the magic pair, you can stop. If you just think of the magic pair off the top of your head, you're better than I am, but you can go ahead and do that. I will say do that at your own risk, partially because there are a lot of people that said, thinking, I can't think of a pair. Rhyme. And then it's like pair number 11, and they missed it. They were skipping around. So I would say do them in order, and for the first few times, list them all out. But if you think you can snatch the magic pair out of thin air, I'm okay with that, as long as it works. So this is good. Find the circle of magic pair. Okay. Now what? Step 4. What do I do with the magic pair? What's its purpose? Go, Fred.
Replace it with the 7x.
Yeah, you plug it in for 7x. Now you do have to change one teeny thing. The multiply has to change to addition. Just, so replace. I can spell, C-E. Replace the middle term. With the sum of the magic pair. The only reason I say sum, so you can change it to plus. So replace the middle term with the sum of the magic pair. Can somebody read that off for me from beginning to end? Therese, go for it. Just this thing, but replace it with that.
Wait, what do you want me to do?
Just read off the original problem, but
Six.
instead of 7x, replace it with this.
6x squared
Yep.
plus 9x.
9x.
Plus negative 2x.
Yep.
Plus negative 3.
Plus -3. Does that make sense? I'm replacing this with a magic arrow and a plus. Did somebody finish this problem? Go. Factor by grouping.
And then.
Step 5 is factor. Let me write this down. Factor by grouping. I'll be out of the way in just a second. Okay, talk me through it. Ron.
And then, the GCF of 6x squared and 9x is 3x.
3x. What's left behind?
2x plus 3.
2x was 3. Good. How about this?
And then,
I can only see one thing that could come out, and I'm looking at this.
negative 1.
-1. Nice. By the way, I could have even pulled out a 1 if I needed a pair. But go ahead. What's left behind?
And then it's 2x plus 3.
Plus 3, because the negatives got yanked. Is this going to work? Yeah. What happens now? Let me see. Andy, finish up.
Maybe 2x plus 3.
Yeah. Pull the 2x plus 3 out in front. And then what's the leftovers?
3x plus negative 1.
And you're done. That's factoring by magic pair. Okay. Yeah.
I got the same answer, but the 3x plus negative 1 was in front. Does that matter?
Oh, did you put negative 2x plus 9x? That's perfectly fine. Yeah.
It's just like-
As long as you switch these around, it's kind of like on FOIL, where if you switch the middle pair, you're fine. Because commutative property says addition can flip with no problem. Yeah, that's perfectly okay. I have, I was going to say good news and bad news because I say that a lot, but I have news. I have a few more notes I wanted to type, and we are against the wall here. So I'm sure this will crush everybody's evening, but I'm afraid I cannot give you homework tonight. So in class 60, yeah, I know, everybody's going to be weeping in their favorite beverage. In class 65 is not going to be due tomorrow. Did I hand it out yet or no?
No.
I will let you see it. Can't let you see it if I don't have it. Oh, here it is. Okay, got it. Here's in class 65. You can look it over. There are some review problems. You might want to start on those early so you don't have to do them tomorrow night.
Are we gonna have to do all of them tomorrow?
Yep. So if you want to do the review problems ahead of time, you'll have a lot less work later. But I'll leave that up to you. This entire thing easy. This thing feels thick. This has lots and lots of reading. There's a step-by-step explanation of how to do it. We did it already. So there are actually only 30 problems. And that is about all I have time for. So hang on to these, don't lose them. Bring them tomorrow. We're going to be working on them in groups tomorrow, as much as we can. And please stand.
Yeah, we do.
Arise, surgite. Heads orange. In the name of the Father, and the Son, and of the Holy Spirit. Amen. Glory be to the Father, and to the Son, and to the Holy Spirit, as it was in the beginning, is now, and ever shall be, world without end. Amen. In the name of the Father, and of the Son, and of the Holy Spirit. Amen. Yeah, please.